Hello everyone, here is Andrea, and in this video I'm going to show you how to create and use a button and how to incorporate a button, more precisely a slider, within a Matplotlib window, and in order to be able to change by toggling the slider some parameters of a plot, and to see the direct consequences, the changes in the plot right in the window that is still open. And so this is very useful, I think, because lots of times when we are plotting some graphs or some functions, we are also interested in see how the plot is changing while we if we were to modify some of the parameters or some of the variables. But most of the times, if we're not using these specific widgets, the only possibility is to just close the window and then go back, change the variables or the parameters in the script, and replot and see the different graph. While in this way, we could be able to change by simply changing the value on the slider, that we will create the parameter that are describing our function, and see the direct consequences directly on the opened window, which I think is a very powerful tool to learn. Also because it's very easy, as you will see. More precisely, I will try to make a slider button which will be responsible for changing a parameter in the definition of a spline curve. Sorry, and we will see as the effect of changing the parameters of the spline in how the spline curve will fit a given function. So I'm just starting by importing the packages and the libraries that we will need for this tutorial. So the first thing to import is NumPy, SMB. Now, since as I told you, we will create a spline function. I will import from the SciPy interpolate package. I will import the univariate spline function, which is a function that allows you to create a spline curve, which will interpolate a given function. If you want to know more about spline functions and spline methods, I also wrote an article and also a tutorial on splines, and check that in the blog. I will import then Matplotlib, because of course, as I told you, we want to plot our data and then to modify them as well. Sorry, BLT. And finally, from Matplotlib .widget, we have to import slider, which is the name of which is the function, let's say, that is describing the button that I'm interested in for this tutorial. Matplotlib Widgets is a package that includes different others types of buttons. In this tutorial, we will focus only on slider, but there are quite a lot of different widgets that can be used and can be incorporated in your plot. So after defining after importing the packages and the libraries, I'm going to define the initial function that we will use to be fitted with the spline. So I can just write a comment here. Let's say initial function, And as you may already know, to define a function, I will need an X array and a Y array. The X array will be called X and will be defined by simply using the numpy function line space from 0, let's say, to 10, and I want 30 values. So yeah, there are 30 equally spaced values from 0 to 10. Then let's define the Y array. For the Y array, I want to have more, let's say, complex function, just to make the spline interpolation a little bit trickier, in order then to be able to change some parameters of the spline and see an actual effect on its degree of interpolation. So let's try with sine of 0.5 times x of times, let's say again numpy against sine, and let's use the random function x time numpy random dot random 30. This function, I already used that in multiple tutorials, and it allows you to obtain samples from a standard distributions, and the only input that you have to give it in is the size of the array that you want to generate. And that's it. This is the function. We can then define the spline interpolation, and as you may remember, if you have already watched my tutorial on spline, I will call the spline function spline, and I'll call the function univariate spline, and as inputs I have to give the X and the Y array, and then among all the parameters that I could specify, I want to focus my attention on the smoothing factor, which will be the parameter that we will try to modify through our slider, and I will take it equal to 6, which is pretty high, but this is because I wanted to see an effect when changing its value. And then I'll just have to redefine the X and the Y array of the spline to perform the interpolation. So X spline is equal to numpy linspace, linspace, and it has to be a denser array, so from 0 to 10, and I will take, let's say, 1000 values. I think it's a little bit overkilling, but yeah, let's keep it in that way. And then the Y spline array, which is the array that contains the values, the Y values of the spline curve, and we just have to apply the spline function just defined to the X array, and that's it. So basically, at the moment, we've just defined our initial function and the spline function that is used to interpolate it. At this moment, we just have to. The next step is to plot these functions and the spline, and to create the slider. So let's go with the plotting of the function. Let's insert here a comment. So let's go with the usual comments for plotting. lt.figure ex dot equals fig.subplots. Okay, and then I can show you how the function looks like and how the spline looks like right now, I will just define a new variable p in which we will store the plot. And this is done for then being able to refer to this variable, to the variable containing the plot, and being able to modify some aspects of the plot through the slider. So I'm plotting the first, the initial function, and then I'll plot also the spline, which is defined by the X spline array and the Y spline array, and I will just give it the color green. So let's see if it works. plt.show. Okay, the blue one is the actual function, the initial function, and the green curve is the spline. As you can see, since we gave a very high smoothing factor, the spline interpolation is very bad. So we will now proceed further in the definition of the slider button, and with which we will try to improve this interpolation. Sorry. So to be able to insert the spline, the slider button, sorry, we have, I will just try to move a little bit upwards the plot window, just to create some space for the button, and I will do that with this command, subplots adjust, and I will specify what I want to adjust, and I want to create some space at the bottom of the plot, equal to 0.25, and as you can see with this command, I just shifted the plot windows a little bit upwards to create some space here in which I will insert the slider button. Okay, let's move on. So I will just create some space because now I have to define the slider button. So defining the slider button. So the first thing to do is to create basically the space, the window, or as you can call it, you might call it the axis that are defining the button, and I'll call it AX slide, and it's a Matplotlib function called axis, and in this function we basically enter a list of values which are used to specify the x and the y position of these axes that are defining the button, and the width and the height of the button itself. So I'll go with 0.25 for the x horizontal position. It's the position of the left border actually. 0.1 for the vertical position, and then I will go with a width of 0.65 and a height of 0.03. So just I can specify these parameters here just to have a reminder. They are the x position, y position, width, and height. Perfect. I can then try again to plot the result to see what I just created. Here I just created this, which are the axes in which I will insert the slider button here. Now we have to give some properties, to enter some properties of the button that will be placed in this space. Okay, so let's define the properties of our button. So properties of the slider. to do this, we will use the function slider that we define here at the beginning of the script. So I will call it sFactor. Since with this slider, I'm going to apply some modifications to the smoothing factor of the spline. And I'll call the function slider here, and I will have to, the input of this function there are quite a lot of inputs. I will just have to enter where I want to create the button, in which axis I want to create the button, and which are the AX slide, which is basically the space that I just created for allocating the button. I have to specify also the label with which I want to call the button. I think this is some sort of optional parameter, but it's better to specify what your button, what your slider is used for. The next two values that I'm going to enter are the minimum value of the slider and the maximum value of the slider. I think that I can just type the numbers, the actual numbers, but I can also use this val min equal to 0.1 and val max equal to 6. Another thing that I want to specify is the initial value that will be present in the slider, and it's val init, and I want it to be equal to the first value that I just plotted here, which is 6 for the smoothing factor. And the last parameter that I want to enter is the val step, which is the step increment that it will be taken when sliding the slider back and forth. And let's use like 0.2, seems reasonable. Yeah, and that's it. At this point we have just defined our slider and its properties, so its name, the label, its values, and so on. We, as you can see here, let's plot it. Here it is, the slider. We can already play with the slider, decreasing and increasing its value here, that is reported here. As you can see, the increment is of 0.2, and but as you can see, by sliding the slider, we are not making any change in the plot, and this is because basically the slider and the plot are still are not connected. So we have to specify how the value contained in this slider is connected to the graph here to be able to see some effects. To do that, we have to define a function in which we will basically tell how to modify the plot. So let's make another comment to say updating the function. Well, better than the function, the plot, I think. As I told you, I have to define a function, so def, we'll call it update, and this function accepts as input a value. I'll call it val, which will be the value stored in the slider. And what we have to do, I have to create a local variable called current value, current v, and this current value will be equal to the value that is stored in the smoothing factor of the spline. I'll use this method here as factor.val to obtain the value of that variable. Then after that, once we have the smoothing factor within that is characterizing the spline, we have to redefine to repeat the spline interpolation. So I will just define again well, I can just copy paste here this here, and with the only difference is that this time the smoothing factor will be dictated by the value that is stored in the current v variable. Perfect. And yeah, once we have repeated the spline interpolation, we just have to set the new value in the plot. So I'll do that with this comment here, p is the variable in which we stored here the plot. So p dot set y data, and the y data that we want to set is the spline function just defined in the above line, and it is applied to the usual x to the denser x array x spline. Perfect. So basically we stored the current value of the smoothing factor in this variable. We just repeated the spline interpolation, this time using the smoothing as a smoothing factor the current value that was initialized, and then we just changed the y data that are displayed in the p variable, which is the plot. The next comment that we have to do is to basically redraw the figure, and this can be done by typing fig.canvas.draw. So as I told you, I will leave a comment here, redraw the figure without closing the window, of course. Yes, I think that we're basically done. The only thing that is missing is the condition that specifies when this function, this update function, will be called. Just another thing, I was quite forgetting about that. We have to place a comma here, which will allow to unpack the value contained in this variable, and in order to be able to modify the plot every time we will make any modification through this function. Okay, so we just have to specify when the function update will be called. So and this can be done by this s factor, which is the smoothing factor. It's the value of it's the slider, basically the value stored within the slider. Dot unchanged, which means that every time the value of the slider that is stored within the slider is changed, we can do something the something that we want to do, we can specify it in here. And what we want to do is we want to call the update function every time the value of the slider will be changed. So basically, to describe the process, every time the value within the s factor, which is the slider, will be changed, we call the update function. And what we do in the update function, we basically store in this local variable the value of the slider. We then repeat the spline interpolation using as a smoothing factor the new value stored within the slider and in the local variable. Then we just set again the y data with this new spline interpolation, and then we just redraw the whole figure. I think that we are done. Basically, we can just plot. I will just type a comment, and so in this last line, we just tell that to calling the function. It's called update. When the value of the slider is changed. Perfect. I think we are basically done. Yeah, it's very important to remember the comma here, because otherwise the script will not work, because we will not refer to the value stored in this variable. So let's see how it looks like. Perfect. So here we have our window, our plot with the spline. At this moment, the smoothing factor is equal to 6, as we also define here in the first call of the spline. And our smoothing factor slider have an initial value of 6, as we have initialized here. And then, as you can see, if I've done the things correctly, as I will change the value of the slider, the spline function will slowly change. Yeah, it's working. And as I decrease the smoothing factor, the spline interpolation should get better and better. Let's see, I can just go down. Because the smoothing factor is basically governing the number of knots that are used for the spline. So the higher the number of knots, the better the interpolation. As you can see, yeah, it's improving quite a lot. And as we go down, yeah, this is the final value. This is quite a perfect interpolation of the function. And this is the minimum value, which is 0.1. If I turn on again towards our higher value, the results becomes again worse. And as you can see, it continues to update in real time. So here it is. I think we're done. This was all for this tutorial. I think, as I told you at the beginning, that implementing these slider buttons in your plots is a very useful and powerful tool, because you're able basically to change to leave some variable values within your plots, and to see how your plot may, or your function, or your feed maybe will change when you are actually changing the values of those parameters, which I think it's a really cool thing also to show in like a presentation or a meeting and so on, just to improve the comprehension of what you just did. So hope that it was all clear, and see you in the next video. Bye bye.